Now let's talk about analog gear emulations. You have already seen that tape machine I showed you before in one of the first lessons when showing you distortion. So this tape machine, which actually emulates as if you have recorded something to a tape and then reproduced it back. So in this process, by inserting this on this channel, we are actually recording to a tape and then playing back what we have recorded. So 2-in-1 actually, and this emulates the tape truthfully in a sense that it adds all the nuances that tape brings. And of course, some would not agree and say that the tape has way more to it than just this. But think about it. If you wanted a tape emulation like this without actually having to use a real tape, record to it, clean the heads, deal with the mechanical parts, repair it, and always when you had to record to the tape, you would have to record playback. It takes some time to do. Now, having a lot of this equipment emulated like this means that you can actually put it in your project just like this, save it with the project, and once you open it, it's right there. Now, a lot of the analog equipment, and let's get down to some, let's say, compressors, let's say like this. This is an emulation of an API 2500 compressor, and this compressor, it exists in the real world as hardware, and this is just an emulation of that hardware. But if you wanted to use this as an analog device, and everybody says that these plugins are really close, but they are not the actual real thing. Now, the real thing, if you used it, you would have to record through it, and that's it. Now, imagine if I recorded through a compressor, and then I wanted to change something, but I would have to have the original signal I had, the original sound I had, and run it through this compressor again with different settings, or the same settings, but slightly modified. Now, what if I wanted the same settings slightly modified? Well, I would have to have these settings written down, or as I usually do with my analog hardware, I take a picture. Now, I'm not saying analog is bad. I'm just saying that digital has real advantages to it, that I can have this in a project. Every time I open the project, is already set up the way I wanted it, and I can reuse it or delete it or remove it. What I mean is remove it from the signals path. A really good thing that we have all of these which actually emulate what the analog hardware does. Now, we went through the compressors and why they're different, all the nuances they have, so the characteristics of a compressor, and it's really nice to have this as analog gear because it was really popular. So let's hear this compressor in action. Let's see what this sounds like. Now you can see when I put the compressor in, it gives that punch to all of the drums, glues down the track but keeps the punch in, and when I turned it off there is no punch on the drums. So just compare the in and out. So when it's in, when it's turned on, then it's actually affecting. When it's out, then it's not doing anything. So check out the difference. And on this compressor, as let's say some of the special things that it has is this tone, and it's just a thrust for the detector. So it's a EQ being applied to the same signal that the compressor is listening to, but only on the detection field. So it's not changing with that EQ the signal that we're actually affecting. It's only changing the part of the signal that goes into the detection field. So it's applying on the normal, nothing, so it's all straight, the same signal that we are listening to. With the medium, we're actually getting a curve that amplifies the highs a tiny bit, almost like a shelf, but not really. It's a linear progression from a certain point, and also lowers the low frequencies at some point. And the loud actually does the same thing, but even more extreme. So when doing this, we're actually changing the spectral balance of the signal going into the detection field. We can change the knee to be hard, medium, soft, and we can link or unlink the channels that we are compressing. So the left and right could be independently, as you see, independently compressed. Now this filter right here is a filter that we can use on this linkage circuit, where we can actually exclude some frequencies with the high pass, low pass, or both, creating a band pass from this linked parameter. So now we have both of these channels linked, so that if one passes the threshold, the other one gets compressed too, but we could exclude some frequencies from that link, meaning that when this is done, high and low frequencies on one are not going to affect the compression on the other. Now the last parameter is right here, the feed forward or feed back. Now this would tell you if the signal being put through the detection circuit right here is taking after the compression is applied or before the actual compression is applied. So before this whole module right here that is actually applying the compression, that VCA, that voltage controlled compressor. So if we are listening to the signal after it or before it. So this is the button that changes that, and it gives a different character to the compressor. Let's hear that. So you can see it creates quite a difference in a way in which the threshold actually reacts to the signal. And of course, from all of these, we have the output, we have the metering that we can choose, of course, we have the output, and we can choose if we want manual makeup or want the automatic makeup. So the more we push down on the threshold, the more gain on the output we get, considering that if we push the threshold more, we're getting more compression, so we want to make up for that with the output gain. Now we can turn off the automatic, gaining of the output and just have it on manual. This is the in and out, so bypass all the functionality of the entire compressor, and this is the analog modeling, as they call it. So it's modeling what was analog about this compressor, what made it unique. Now we have a lot of these hardware devices that were actually made into software, just like another API EQ or this EQ, so 3-point equalizer with 3 filters. So all of these are just emulations of analog hardware gear. And when doing this, they actually try to recreate in the best possible way all the nuances and all the little errors that these analog devices had, hence giving us the experience of using those analog devices, and the people who actually have them and like them, they would get almost the same thing, but now in digital, meaning that if they wanted to recall a certain preset, they could. So we have a lot of devices just like this, emulated into digital gear. Usually when doing that, designers of those effects actually try to make these compressors, equalizers, all of this equipment being virtualized, they try to make it look like the actual real thing. Now, on some of those, we have some added things that were not on the original device, just for ease of use, but there are many of these devices modeled. I'll try to go through some of those, but compressors and EQs, most popular, of course, and waves has done a lot of those devices. A lot of the devices done were actually to emulate the most popular analog gear used. Let's say we have this compressor also, which is the emulation of a Fairchild compressor. We also have, let's say, an emulation of this Pultec equalizer for the mid-range, also emulation of this Pultec equalizer for lows and highs. And I showed you this one even in one of the lessons before. So a lot of these are emulated just to give us some analog experience of the gear that actually sounded just like that. Now, some people want this because they actually have this analog gear, but they want it digital so that they could use it with more flexibility. As I've told you already, imagine if you really had this thing. And this is a channel strip from a console. So this would be virtually one channel out of a big mixing desk. So imagine having this and you moved some knobs to certain positions just like that. How would you remember all of those? You would have to take a picture. So usually before, when analog mixers were analog, didn't have any automation on them, they weren't digitalized so that, all of those faders could move by themselves. You would do a mix, print it out, record that mix, and that was it. You would do a next mix, so you would reset the entire mixer. Now imagine that if somebody told you, okay, I don't like this, I want it better, you would have to do it all over again. Or at least print the mix, send it out, wait for the opinion, and not use your mixing console in the meantime. Now, nobody would do that. You could, of course, take a note of each and every parameter you moved on your analog mixer and then recreate it again when you wanted to do that mix again. And that was actually done also using paper with holes for these buttons, and you would mark on the paper where the button is turned so that you could recreate the exact same, conditions you had when you mixed a track. So this really makes it easier, having all of this equipment, virtualized in your computer so that you could use it, turn the knobs, and they would be remembered. So all the positions of all your virtual hardware gets, remembered. Let's see, there's another console. Also, you see recreated. So all of these are just there to try to emulate it audio hardware because it has some nuances and it's really popular and sounds nice for those nuances. And believe me, most of the music you heard has nuances of all of these analog devices, at least the music that was mixed in the analog hardware era. Now, it's praised for that, and for that same reason, this is why it's being emulated.